Beyond the reaches of our solar system lies a vast expanse of undiscovered worlds, each with the potential to harbor life. It may be life as we know it, or perhaps vastly different from our own. Among the thousands of exoplanets detected by our powerful telescopes, a handful have emerged as prime candidates in the search for extraterrestrial life. These promising planets possess characteristics remarkably similar to Earth: the right size, the right orbit, and the possibility of liquid water on their surface. But could these distant worlds actually be better than Earth? Might life have already gained a foothold in places we barely glimpsed through our lenses? Let's examine some of the most Earth-like exoplanets found to date and ponder whether they could be home to alien life superior to our own. As we push the boundaries of known space, the possibilities captivate our imagination. Perhaps among the stars lies a planet more spectacular than we could have dreamed, waiting to be uncovered. First, we travel 1,800 light-years away to Kepler 452b, which is frequently dubbed as Earth 2.0 or Earth's cousin due to its characteristics. This super-Earth exoplanet located in the inner reaches of the habitable zone surrounding the Sun, like star Kepler 452, could harbor life. It is the only exoplanet in the Kepler system identified by the Kepler spacecraft. Its location lies approximately 1,800 light-years, or 550 parsecs, away from Earth within the Cygnus constellation. Kepler 452b orbits its host star at a distance of 1.04 astronomical units, or about 156 million kilometers or 97 million miles. This distance is similar to Earth's distance from the Sun. It has a roughly 385-day period in orbit, a mass at least 5 times that of Earth, and a circumference that's 1.5 times bigger than Earth. It is likely that Kepler 452b is a rocky planet, despite its uncertain composition, but it's not clear if Kepler 452b is suitable for habitable conditions. It orbits a G2V type star that is similar to our Sun, but 20% brighter and with the same temperature and mass. Notably, this star is considerably older, clocking in at around 6 billion years old, which is 1.5 billion years older than our Sun. Kepler 452b currently receives 10% more energy from its parent star than Earth does from the Sun. If Kepler 452b is rocky, it could experience a runaway greenhouse effect similar to Venus. It is, however, possible that Kepler 452b will be able to retain its oceans for an extended period, delaying the onset of a runaway greenhouse effect for approximately 500 million years. This delay could be facilitated by a buffered carbonate silicate cycle and an increase in volcanic activity. It is therefore possible that any prospective life on its surface will have another 500 to 900 million years before the habitable zone shifts beyond Kepler 452b's orbit. It is a solid candidate for future research. We now approach Kepler 442b, also called KOI 4742.1, a confirmed exoplanet of near-Earth size that is likely made of rock. This intriguing world orbits within the habitable zone of its host star, Kepler 442 AK. Type main sequence star located approximately 1206 light-years or 370 parsecs away from Earth in the Lyra constellation. Kepler 442b follows an orbit that positions it at an average distance of about 0.409 astronomical units from its host star. It completes one full revolution in approximately 112.3 days. Kepler 442b has an estimated mass of 2.3 times that of Earth and a radius of roughly 1.34 times our planet. Among the thousands of exoplanets discovered, Kepler 442b stands out as one of the most promising candidates for potential habitability. This is mainly due to its parent star, Kepler 442, being at least 40% less massive than our Sun, implying an extended stable lifespan of about 30 billion years. The Kepler spacecraft first identified this fascinating exoplanet using the transit method, observing periodic dimming of Kepler 442's brightness as Kepler 442b passes in front of it. NASA officially confirmed the existence of Kepler 442b on January 6, 2015. Kepler 442b's position within the habitable zone of its star means liquid water could plausibly exist on its surface, given the right conditions. It exhibits a high degree of similarity to Earth in both size and estimated surface temperature. The planet also lies just outside the distance where tidal forces from its star would lead to complete tidal locking. As of 2018, Kepler 442b was regarded as the most potentially habitable, non-tidally locked exoplanet found to date. In 2015, a review essay said that Kepler 442b, Kepler 186f, and Kepler 62f were all good candidates for planets that might be habitable. In the same year, a tool called the Habitability Index said that Kepler 442b is more likely to be habitable than a hypothetical Earth twin with similar physical and orbital characteristics. But it's not certain if Kepler 442b can be used as a home or if it already has life yet, because we need additional information about its atmosphere and surface. The Habitability Index does not imply that Kepler 442b is more habitable than Earth. Instead, it reflects its potential based on available parameters. Traveling now to Kepler 1649c, an Earth-sized exoplanet that resides within the habitable zone of the red dwarf star Kepler 1649. This planet is the outermost member of the planetary system that the Kepler Space Telescope has found. It is about 301 light-years, or 92 parsecs, away from Earth and is part of the Cygnus constellation. Kepler 1649c maintains a distance of approximately 0.0649 astronomical units, or around 9.71 million kilometers, or 6.03 million miles, from its host star. It completes its orbit in approximately 19.5 days. It has a mass of 1.2 times that of Earth and a radius of roughly 1.02 times that of our home planet. These characteristics suggest that Kepler 1649c is probably a terrestrial planet. However, its proximity to the star suggests that it could be subject to tidal locking. The director of SET's K2 Science Office, Jeff Coughlin, hailed Kepler 1649c as the most Earth-like planet discovered by the Kepler Space Telescope in 2017. Kepler 1649c does indeed orbit its star's habitable zone, but there is no information about its atmosphere, so it's not clear if it can hold liquid water on its surface. As of 2020, no solar flare-ups have been observed from the host star. Scientists warn, however, that stars like this one are prone to frequent solar flares, which could have repercussions for the planet's atmosphere and the possibility of life. The specifics of Kepler 1649c climate also remain largely unknown. It gets 75% of the light from its host star that Earth gets from the Sun. Therefore, depending on its atmospheric composition, its surface temperature may be similar to Earth's, which might allow liquid water to flow. However, the composition of its atmosphere is still a mystery. Orbital evolution models show that Kepler 1649c may have a lot of eccentricity oscillations because of gravitational influences from Kepler 1649. Despite this, for most initial parameters, the planet's climate is projected to maintain Earth-like conditions. This could be ideal for habitability, which further gives it a greater chance of already harboring life. Let's jump to TOI 700, a red dwarf star located approximately 101.4 light-years away from Earth in the Dorado constellation. It is notable for hosting TOI 700d and TOI 700e, both Earth-sized exoplanets situated within the habitable zone. This discovery was made possible by the Transiting Exoplanet Survey satellite, TESS. The TESS team has identified 4 exoplanets orbiting TOI 700, and it is likely that all 4 of them are tidally locked to the star. Regarding the composition of these exoplanets, planets B and D are more likely to have rocky compositions, while planet C is thought to resemble Neptune in terms of composition. These planets have interesting aspects about how they formed and changed over time. The inner planets may have experienced rapid growth and accumulated substantial gaseous envelopes, with the possibility of the innermost planet losing its envelope due to photoevaporation. Another possibility is long-term planetary migration, especially with Planet C potentially migrating inwards. The habitable zone of TOI 700e receives a different amount of UV photons than the habitable zone of Earth and TRAPPIST-1e. Simulations suggest that a planet with Earth-like pressure could maintain its atmosphere for over 1 billion years, even though the host star shows low stellar activity. Although the limitations in spectral features and flux variations make it challenging for James Webb to characterize its atmosphere, TOI 700 is considered a strong candidate for habitability. In November 2021, a fourth potential planet, TOI 700e, was discovered. The TOI 700 receives around 30% more flux from the Sun than the Earth does. NASA's tests discovered that TOI 700e has a mass of about 0.8 Earths and orbits its star in 27.8 days. It is within the habitable zone, which indicates that there is potential for liquid water on its surface. Though slightly smaller than its neighbor, TOI 700d, both planets hold promise for habitability. More research and data collection on the TOI 700 solar system is important for improving our understanding of Earth-like planets. Now we travel to a planet that probably has an incredibly difficult name to remember. EPIC 206209135.4, better known as K272e, a confirmed exoplanet, most likely composed of rock, and orbits within the habitable zone of the red dwarf star K272. It is believed that this celestial body is the outermost of 4 planets unveiled in the system through NASA's Kepler spacecraft during its second light mission. It is located approximately 217.1 light-years from Earth within the Aquarius constellation. It was discovered using the transit method, a technique that gauges the dimming effect occurring when a planet passes in front of its host star. K272e has characteristics similar to Earth in terms of mass and radius, being classified as an Earth-sized exoplanet. It has a constant temperature of 261 Kelvin, which is equivalent to -12 Celsius or 10 Fahrenheit, and a radius of 1.29 times that of Earth, as well as a mass of 2.2 times that of Earth, depending on its composition. The exoplanet follows an orbit around a red dwarf star known as K272, which has a total planetary entourage of 4. K272e has the longest orbital period. This red dwarf star has a mass equal to 0.27 times that of our Sun, a radius equal to 0.3 times that of our Sun, and a temperature of 3,360 Kelvin, about 3,086 Celsius, despite its age remaining unconfirmed. K272 looks very bright from Earth's perspective. You can't see it with your eyes alone. You need to use a telescope to see it. K272 begins its orbit around its star, completing its roundabout in 24 days, and maintaining a radius that's 1/10 of Earth's distance from the Sun. In contrast to Mercury's orbit, which is 0.38 astronomical units away from the Sun. Regarding habitability, K272e and K272c are located within the habitable zone of their parent star, a region where, under suitable conditions and atmospheric properties, liquid water could potentially exist on the planet's surface. The planet receives 11% more insolation than Earth, which poses a potential risk to any existing oceans. This makes them susceptible to boiling away, potentially diminishing the likelihood of habitability. However, there's always a chance that life has existed there for a very long time. Now we move to KOI 570, 1.5, better known as Kepler 186f, an exoplanet with Earth-like proportions that orbits within the habitable zone of the red dwarf star Kepler 186, which boasts 5 such planets discovered by NASA's Kepler spacecraft. This distant world resides about 580 light-years away from Earth in the Cygnus constellation. Kepler 186f maintains an orbital distance of around 0.43 astronomical units, which is about 64 million kilometers or 40 million miles from its host star, completing its orbit in approximately 130 days. It has a mass of about 1/4 that of Earth and a radius of around 1/7 that of our planet. Due to its Earth-like size and position in the habitable zone, It was one of the more promising candidates for habitability, but its true habitability depends on factors like the presence of an atmosphere, its composition, and the potential for liquid water on its surface, which are unknown. The discovery of Kepler-186f took 3 years of data to find. NASA's Kepler telescope used the transit method to find it. The initial presentation of these findings took place at a conference in March 2014, followed by a public announcement in April 2014 and publication in the journal Science. Kepler-186f is in the habitable zone, but this alone doesn't mean it's habitable because its atmospheric characteristics are still a mystery. Unfortunately, its distance makes it impossible for existing telescopes, including the newest ones, such as the James Webb Space Telescope, to analyze its atmosphere directly. A basic climate model suggests that if the planet's atmosphere contains between 0.5 and 5 bars of CO2 and includes nitrogen, carbon dioxide, and water, the surface temperature could exceed 273 Kelvin, which is about 0 degrees Celsius or 32 Fahrenheit. The star Kepler-186 is home to 4 other planets, but their high temperatures make them unsuitable for supporting liquid water. Kepler-186f is thought to be in a higher orbit with weaker tidal effects from the star, which could avoid tidal locking. Its tilt is likely small, so it doesn't have tilt-induced seasons, and its orbit is expected to be nearly circular, which would reduce seasonal changes. In 2015, a review essay identified Kepler-186f, along with Kepler-442b and Kepler-62f, as some of the best candidates for potential habitable planets. Studies in June 2018 suggested that Kepler-186f might have seasons and a climate similar to Earth's. Kepler-186f definitely looks promising. Now we travel to an exoplanet designated KOI 87.01, better known as Kepler-22b, that comfortably sits within the habitable zone orbiting its sun-like host, Kepler-22. It is located approximately 640 light-years away from Earth in the constellation of Cygnus. NASA's Kepler Space Telescope unveiled its existence in December 2011, marking a groundbreaking achievement as the first transiting planet known to orbit within the habitable zone of a sun-like star. This region is conducive to the potential presence of planets. Because of its dim brightness, Kepler-22 is hard to see with the naked eye. Kepler-22b has a radius approximately double that of Earth, although details regarding its mass and surface composition remain uncertain. But it has been determined that this exoplanet probably has a composition rich in volatile substances and a liquid or gaseous outer layer. According to available data, it has an orbital period of about 290 days and an inclination of about 90 degrees. Existing evidence suggests that the surface temperature of Kepler-22b is moderate under the assumption that the surface is not subjected to extreme greenhouse heating. Lacking an atmosphere, its equilibrium temperature, assuming an Earth-like albedo, would be around 279 Kelvin, which is equivalent to 6 degrees Celsius or 43 Fahrenheit, and slightly higher than Earth's 255 Kelvin, which is equivalent to negative 18 degrees Celsius or negative 1 Fahrenheit. The first transit of this planet was observed on May 12, 2009, and Kepler-22b was formally declared to exist on December 5, 2011. It follows an orbit that positions it at an average distance from its host star, Kepler-22, which is roughly 15% less than the Earth-to-Sun distance. Interestingly, this star has approximately 25% less luminosity than the Sun. With such a short average distance from the star and reduced stellar luminosity, it is possible to have a moderate surface temperature at such a distance, as long as the surface is not subject to extreme greenhouse heating. If Kepler-22b followed a very elliptical orbit, its surface temperature would be very different. In terms of climate considerations, scientists can make a few estimations. Lacking an atmosphere, Kepler-22b would display equilibrium temperatures close to Earth's. If an atmosphere produces a greenhouse effect akin to Earth's magnitude, the average surface temperature could reach 295 Kelvin, which is about 22 Celsius. If the atmosphere were to produce a greenhouse effect comparable to that of Venus, the average surface temperature of Kepler-22b could reach a scorching 733 Kelvin, which is equivalent to 460 Celsius. Recent studies have indicated that Kepler-22b has a 95% chance of being in the empirical habitable zone, which is the area around Venus and early Mars in our solar system. But a 1D cloud-free radiative convective model says that it is unlikely that it will be in the conservative habitable zone, which is in the circumstellar habitable zone. As part of the HAK initiative, researchers have studied data from Kepler-22b to search for changes in the timing and duration of its transits that could indicate the presence of a moon. But these investigations didn't find any evidence, so it's hard to say if there are any satellites with mass of more than 0.54 Earth masses around Kepler-22b. Kepler-22b is positioned as another prime candidate for the search for habitability, as are all planets in today's video. These exoplanets are exemplary examples of what scientists look for when seeking habitability, yet we can only affirm what we found so far. It isn't substantial enough to actually confirm if there is life on these planets, but the search continues, literally with each passing day. New, suitable exoplanets are being found and researched, pushing our knowledge even further. Like the planets on this list, we're just touching the tip of the iceberg. There are numerous others that have been found with similar Earth-like characteristics. While these planets could be even better than Earth and could even harbor extraterrestrial life, with the sheer efforts of scientists and researchers, we will be able to find out sooner rather than later. So what do you think? Which of these planets are the best candidates for extraterrestrial life? And when will human beings be able to travel to these distant worlds? Let us know in the comments below. If you like this video, make sure you subscribe to our channel and leave a like. As always, thanks for watching.